Okay, in this video we're going to look at combining multiple resistors, because combining resistors to find a total resistance of a circuit is a really beneficial technique. Because if you know the total resistance of a circuit and you know the EMF of that circuit, well, you know two things about that circuit and you can work out the current. We'll show you examples of that very shortly. So first of all, we need to look at how do we work out resistance in series and in parallel. So if we have two resistors in series, it's nice and easy, okay? Resistors in series, it's nice and easy. If we've got 200 ohms and 100 ohms, then the resistances simply just add together, okay? And the general rule that we write for this is R total is equal to R1 plus R2 plus R3, or as many R's that you have in series. So in this case, the total R would be 300. That's a very simple example. What happens then when we put them in parallel? So say for example, we've got a 200 ohm resistor and we've got the same 100 ohm resistor, but this time in parallel. Well, we use a very slightly different rule. We do the reciprocal rule. We do 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3, depending on how many are in parallel. Just so you're aware, R3 would be a third one in parallel like that. But we're not going to deal with that right now. We're just going to deal with a nice simple kind of concept. And that is a dot dot dot, because as many as you have in parallel is what you need to do this sum for. So in this case, what we're looking at is we're doing the sum 1 over 200 plus 1 over 100, okay, is equal to 1 over R total. Now, how I would recommend doing this, now obviously some of you might just be able to add these fractions, no problem whatsoever, by doing some simple addition, but when if and when they get more difficult to do, what you'd want to do is you'd want to work out that value, plus 1 over 100. That gives you 0.015. Now that's equal to 1 over R total. So in order to find R total, it's 1 over that value. So 1 divided by that value gives you 66.7 ohms. And so in this case we can see we've got a nice value of total resistance worked out using the reciprocal rule for resistances in parallel. So what we're going to do in a second is we're going to look at seeing if we can do an extra calculation and putting these two rules together to solve a global problem. So here's the circuit one. Right, generally, I call the methodology behind doing this the rule of two. The reason I call it the rule of two is because you want to combine two resistors with each other where possible. Now what I mean is you're either going to combine two resistors in series or two resistors in parallel. And you're going to use one of the other rules depending on whether the two resistors are in series or are in parallel. So, can you see two resistors either that are on their own in series or on their own in parallel? Well, if we look very carefully here, we'll see none of these are just two resistors in parallel. Can't see that anywhere, but what we can see is two resistors in series. So what I'm going to do is I'm going to give these numbers, just some random numbers here. Okay, these are all ohm values. Okay, so what I'm going to do is I'm going to combine these two here. Now, when you combine, or when you stick to this rule of two, then what we can do is we combine resistors into one resistor. So, we can combine these two, we can use the simple R total series rule, they just add together, so we can add those together, we've got 300, 400 there. So we can merge those two resistors because they are the same as one 400 ohm resistor. So, sticking to the rule of two, can you see two resistors in series or in parallel on their own? Well, we can now see that these two resistors are in parallel on their own. And what we can do is we can apply my reciprocal rule to this. So 1 over R total is equal to 1 over 400 plus 1 over 300. And when I work that out in my calculator, I get 0.00583 recurring. So 0.00583 recurring. I will leave that number in my calculator to use as it's displayed, because what I'm going to now do is I'm going to do 1 over that value to get the R total for that section. So R total is 1 over 0.00583. So 1 divided by that answer gives me a total of 171.4 ohms. So, what can I do with this? Well, yeah, I'm going to do exactly the same thing as I did before. I'm going to combine the two resistors I've done the sum for, because of my rule of two, and put them into one. So what we've said is that these two resistors in parallel is the same as one resistor that is 171.4 ohms. So, sticking to the rule of two, can you see two resistors in series or in parallel that are on their own? Well, I'm hoping that you're able to see that's in series with that, with nothing else there now. So the total resistance of the circuit is the addition of these two. So we've got our total for the entire circuit is 371.4 ohms. And that would be my final answer for the resistance of the circuit. Now, where this is really beneficial is where we want to work out the current in an entire circuit. This is really, really useful rule that you can build into using with all your other rules to help you work out these circuit problems. So with this same problem, what I'm going to do is I'm now going to introduce the power supply, which is 12 volts. And I want to know what the current in this circuit is. Okay? So, if I know what the EMF of this circuit is, and I know what the total resistance of this circuit is, we can use Ohm's law to work out our missing value. So, because V is equal to I times R, therefore I want to work out I because I'm looking for the current. So I is equal to V over R, which in this case is 12 divided by our 371.4. And that gives us 0.03 amps. So that is the kind of calculations you'd be expected to do with this combining resistances in series and parallel. I'm going to give you plenty of examples of this in lesson as well for you to have a go at, and we'll see how you do with those there and then. Have a look in your textbook for the reciprocal rules. There's a little, for the rules for resistances in series and parallel. There's a little derivation in there for you. I haven't included it here because I think it's fairly irrelevant. You need to just get to using them more than anything else. But we'll give you some more of these to start off with in the lesson, and we'll see how you do.